Okay, so the next thing we're going to do is an example, but I wanted to show you the steps for constructing a group frequency distribution. And we're going to go through each of these steps. So, it says step 1, determining the classes. And notice there's a bunch of stuff underneath step 1. Determining the classes and the boundaries values for the classes, the class limits and the boundary values for the classes is the biggest work in creating these tables. And then once you have that, you just tally up the data in step 2, and then you find numerical frequencies for the tallies. And we can find what's called cumulative frequencies, and we'll go over that in a second when we get to it. So the example that we're going to do is that example 17 that we started with the raw data. And so the first thing we want to do is we're going to hold on to this raw data. The first thing we want to do is determine the classes. And these are the class limits that we're going to talk about first. Now, if you notice in these directions that we have, it says find the highest and the lowest values, find the range, and we'll define that, select the number of classes desired, find the width, and all this kind of stuff. So we're going to go through all of these things. So the first thing that we want to find is the highest and the lowest value. So highest and lowest. So the way you do that is you just really look over the data. So if I go down this first column, for example, the smallest value in this first column is 53. So I'm looking for something smaller than 53. Here's another 53. Here's a 48. Is there anything smaller than 48? No, so my lowest value is 48. Now we want to find the highest value. So we're looking in the first column. There's a 50, 79. The biggest value is 87, but there's a 92. So we're looking for anything that starts with a 9 to see if there's any bigger number. And here's a 93. So the highest value is 93. Okay, so the range value, that's the next thing we want to find, is the range. The range is the highest minus the lowest. Let's put that on another line. Minus the lowest. So it's just the biggest value minus the smallest value. So in this case, it's 93 minus 48. And if we subtract those, I think we get 45. Okay, so that's our range, is 45. Now the next thing we need to know is how many classes. At this point, either the problem tells me or you got to pick how many classes. Now, to keep things best, or not best, keep things easiest for me to grade, they usually tell us how many classes in the problem. So we want to do 7 classes. All right, now if you had to go for yourself, you would just, there's no really great way to do this. You would probably try a few numbers of classes and see which one seems to keeps the most amount of information without being too much. So you don't want, 40 classes, because then each number would be in its own class or something like that. So you usually, like we said, we want 5 to 20. You usually only pick 20 if you have a huge data set with a wide range of values. Mostly we stay closer to the 5, 7, stuff like that. 5 is probably too low, but that would be if you have a small amount of data. All right, so the next thing that we want to do is find the class width. So there's a way to do this. So the class width is equal to the range divided by the number of classes and then rounded up to the next integer. Okay, so in our case, it's the range is 45 divided by the number of classes, which is 7. If we divide those numbers, you stick it in your calculator and you divide them, I get 6.42. So the width is going to be 7. Now, what happens if when you divide and you get an integer value already? So this is something to remember because it's an odd thing. if I could ever spell remember. Okay, so if, let's say we had 9 classes, and we still had a range of 45. So if I went 45 divided by 9, I'd get 5. And I got an integer value. So then the class width still has to be rounded up to the next integer. So the class width would be 6. If you end up with an integer value for your range divided by the number of classes, then you round up to the next integer for your class width. Always round up to the next integer. Okay? Now we're going to start building our table. And the way we build the table is we first put the lower limits of each class, and then we put the upper limits. Okay, so start building the table by listing lower limits of each class. Now remember, we only have 7 classes, and we're going to start with the minimum or the lowest data point. So this lowest data point of 48. So start with lowest data point. So our smallest data point is 48. Now class width, remember, is always adding to that lower limit to get the next limit. So 48 plus 7 is 55. 55 plus 7 is 62. Then 69, 76, 83, and 90. I'm adding 7 each time because 7 is our class width. So each time I go up, I add 7. Okay. Now over here, this is always one value less than what we had. So 48. If I ended at 55, this one's gonna be 54. And so notice that 54 minus 48 is 6. Right? And so each distance here is a distance of 6. Or you can always say it's 1 less than the next lower limit. So we don't want them to overlap, so we always got to go smaller. 68, 75, 82, 89, and each time we went up 6, so this last one is 96. Okay, so these are our class limits. Okay. Now the next thing we want to find are class boundaries. And what the boundaries do, is they kind of see that there's a gap from 54 to 55, 61 to 62. There's this gap in data, and we want to fill in that gap, but we want to do it evenly. So what I do is, for the boundaries, to know how much to add and subtract on each side, we take the difference between the upper limit of class 1 and the lower limit of class 2. So difference between upper limit of class 1 and lower limit of class 2. And divide by 2. So we split that difference in half. So if we look up here, the lower limit of class 2 is 55 minus the upper limit of class 1, which is 54. And we're going to divide by 2. And that's going to give us 1/2, or I'm going to write it as a decimal 0.5. Now we subtract 0.5 from all the lower limits and add 0.5 to all the upper limits. And this will give us our boundaries. Okay, so if we look up here at our boundaries, we're going to go 48 minus 0.5. And so 48 minus 0.5 is 47.5. That becomes our lower boundary, and then the upper boundary is 54.5. Now 55 minus 0.5 is going to be that 54.5. And notice on boundaries, this upper and lower have now come to equal each other. And that's important. That'll only happen on boundaries. It can't happen on limits. It can only happen on boundaries. And then this is going to go to 61.5. Then we're going to start over here at 61.5 and go to 68.5. And then 68.5 to 75.5. 75.5 to 82.5, 82.5 to 89.5, and then 89.5 to 96.5. Now what we've done is filled in that gap between those values. And there won't be any data points that actually land on that 54.5 and stuff, because all the data points are integer values. They won't be decimal values. We saw that in our data set. So these are all the class limits and the class boundaries. So the next thing we have to do is a tally. Okay, and this is, as we saw before, it's not super fun. Let me grab this for a second and bring it down so we can kind of look at it. I'm going to put it over our writing at the moment if that's going to... Nah, that won't look good. So how can I do this? Okay, so here's our data set. I don't know where to stick it so you guys can see it best. Yeah, it doesn't want to... Let me make it a little bit smaller and we'll stick it over here for a second. Okay, so what we want to do is go down each column or go across each row and put those values in the right category. So, for example, 59 would fall between 54 and 61, so I'd get a tally mark for there. And then 76 would be in this class, and 64 would be in this class, and then you keep going on down. So take a moment and do that. I'm going to move this over and make your data, separate your data out. And so when we do that, let me put this down here for a minute. I get the following. So when I separated it out, and I did it one by one and went through the columns and put it in there. It's better than going through and looking for all the 50s and all the 60s and all the 70s, because you tend to miss something when you do it that way. But if you go through down the columns and just make sure every data point gets a tally mark in its appropriate class, then you catch all the tally marks. So when I did that, I got 3 tally marks here, 2 here, all right, when I did that, I had this as my tally sheet, all right? And then once you get your tallies, you want to add them up, so you want your frequency. And frequency is just adding up your tally marks and putting that value there. So this is 3, 2, 9, 10, 13, 8, 3, and 2. And you should always add up all your tallies to make sure you have the right number. And when we add this up, we get 40. And remember, we started with 40 different states. These were wind speeds of 40, and highest wind speed in 40 different states. The last thing we want to do with this thing is a cumulative frequency. And I do it slightly different than the book. You can do it the book way. Cumulative frequency. What I do is I create a last column over here. The cumulative frequency is the number of data points less than or equal to the highest boundary in that class. So for example, in this first class, the number of data points less than or equal to 54.5 is 3. In the second class, the number of data points less than or equal to 61.5 is the 3 in the first class plus 2 in the second class. So altogether there are 5. Those data points less than 68.5 are the 5 in the first 2 classes plus 9, so that's 14. And then the next one is going to be this 14 plus 13, which is 27. And then 27 plus 8 is 35. 35 plus 3, I'm adding these over, is going to be 38. And then 38 plus 2 is 40. You should always end with the total number of data points you have. So that's our cumulative frequency term. Okay. All right, so that's the end of that example. I'm going to do an example of some boundary values, and we'll be doing these frequency distributions in our homework. All right, so I'm going to end this video, and then we're going to do one more set of examples for the homework.